Hi, welcome to this SAP Tech Bytes video series where we will deep dive into the major building blocks of the Edge Integration Cell. The Edge Integration Cell is part of SAP Integration Suite's product offering that enables customers to now deploy their integration flows and APIs in a customer managed private cloud region, as well as hyperscaler managed Kubernetes environments as well, thereby offering customers a hybrid deployment option in addition to the fully SAP managed software as a service offering as well. Our idea is to put this video series out where we will bring to you major portions of the functionality. Of course, it's not functionally very different from the integration suite as you've classically known, but given that this is a customer IT managed Kubernetes component, this series will specifically get into those aspects. All right, so let's kick the tires by talking about the installation experience. As you know, Edge Integration Cell is a hybrid setup that depends on a customer managed Kubernetes environment. There are a bunch of prerequisites that need to be met in order to perform a successful installation. First up, it is recommended that you have SAP BTP's sub-account administrator privileges. You or your IT team should have the privileges to spin up a Kubernetes cluster in either Amazon EKS, Microsoft AKS. We also support SUSE Rancher based installation that uses RKE2 Kubernetes version. It is also preferred that you have access to the Kubernetes command line tool, kubectl, to look into some of the system internals, but this is totally optional. You will need a technical P user credential. This user context will be used primarily to perform an implicit Cloud Connector installation during the Kubernetes bootstrapping process. You will need an S user to access the SAP Repositories Management UI, from where we will create another set of technical users to transfer the needed container registries. An optional but recommended component is an SAP Cloud Identity Service IaaS tenant based on OpenID Connect Trust to enable system monitoring. You will need a private key and a CA assigned server certificate for the HTTPS handshake and Istio ingress gateway controllers. And last but not the least, you will need a control of the DNS registry to perform DNS mappings between the load balancer IPs and the virtual host alias of your runtime. Let's start the sequence by first activating the Edge Integration Cell and performing the needed BTP role assignments. Let's log into the Integration Suite app. Here I'm logged in as a user who has the authorizations to provision capabilities, basically has the integration provisioner role collection. You can now see the addition of a new menu option within settings called Runtime. This is where the settings for the edge nodes reside. The first thing I'll need to do is to activate the Edge Integration Cell capabilities. Under the hood, this creates an internal subscription for a service called Edge Lifecycle Management, or ELM in short. And this is something that Integration Suite implicitly uses for the entire runtime management. This will take a couple of minutes, and once the activation is done, you will need to go to the BTP cockpit and assign users the needed roles to proceed with the installation procedure. Let's create a role collection called Edge LM Access. This role collection will need to be assigned to a role called Edge LM Access that got created after the activation step. And the last thing we'll need to do is to assign the role collection to my logged in user, and more importantly, a technical P user that the system will implicitly use for Cloud Connector configurations during the initial bootstrapping step. More on this later. Let's now look for the Cloud Connector Administrator role collection and make sure to assign the same P user to this collection as well. This is a mandatory step. Step 1 is done. Let's proceed with the Edge Lifecycle Management settings. Heading back to the ALM page, let's start by going about the one-time tenant settings section. Like I said, we will need the credentials of our technical P user here within this business technology platform settings section. Next, we will need a different set of technical users credentials to establish the repository-based shipment channel. Log into the SAP Repositories Management UI with your S user, C user, or I user credential, as your case may be. Add a new technical user, give it a name, and note that a system prefix will be added here. Copy the full username into the ELM UI, grab the password, and after testing the connection, you can save your settings. Bear in mind that these settings will expire in 6 months, so you will need to keep these two sets of credentials up to date. Next, let's set up connections to the Grafana-based monitoring and logging section. Here you will need an SAP Cloud Identity Services IaaS tenant that is set up with OpenID Connect Trust with your BTP sub account. If you don't have one, this step is optional and can be skipped. Once I log into my IaaS account, let me grab the IaaS host and copy this into the FQDN text box. Open groups within users and authorizations tab, and you can see that I have a group created here called EIC monitoring user group. Let me copy this and paste it into the group name text box. Next, let's head to the applications and resources section, applications, and create a new application. Let's give this the same name as our BTP sub account and make sure to set this up with OpenID Connect and not SAML. Copy the application identifier from the URL and paste it right back into the application ID section. Within the client authentication section, add a new client secret and save. Make sure you copy your client credentials and copy them over into the respective fields in our ELM configuration UI page and save. Looks like I forgot a step to set the assertion attributes. So let's head back to our IaaS page, access the attributes tab and add a new attribute called groups with a lowercase g and map it to the group attribute from the source identity provider. Click save, and let's finally save our ELM settings as well. With this one-time tenant settings done, let's now get into step 2, that is adding an edge node. We begin the process by acknowledging that there are a bunch of prerequisites in terms of documentation that have been met. More on these steps later. Let's give the edge node a name. I would like to point out that here in this installation journey, we've selected the simplest of settings. Please do follow the documentation for alternate settings and advanced options, which we will try and cover in other video segments of this series. Let's call this S4HANA on-premise node. Yes, I want to enable monitoring and logging. We don't need a local container registry for now. HTTPS proxy is not needed. And let's confirm our selection. At this point, we need to input the kubeconfig file that contains the cluster and context of the Kubernetes service where the edge node is being installed into. Let's pause the edge node creation process for a bit, take a step back and have a look at how the Kubernetes platform was set up. Here we are using AKS, Microsoft's Azure Kubernetes service, to spin up a managed Kubernetes instance. The other options we support at this moment of recording are Amazon's EKS or a fully on-prem SUSE Rancher's RKE2 Kubernetes platform. We begin by creating a resource group that will host our Kubernetes service and other related assets. Let's give this a name and a primary region. Next, let's spin up a Kubernetes service within the resource group. Let's set this to a product standard preset. I'm going to give this a name and let's select 3 availability zones within this region. Now it needs to be told that selecting 3 availability zones is mandatory should you want to perform an HA setup of the edge integration cell. In this video, we will not demonstrate an HA setup. This is something that we will try and cover in a subsequent video. The other aspect is to select a Kubernetes version as per the product availability matrix or PAM. At this moment of recording, we support 1.25.x and higher versions. Let's select 1.25.11 and proceed with the cluster creation process. Next, we need to size the node pools. For the user pool, I'm going to select an 8-core 32 GB RAM D8S V3 machine. Please make sure to refer back to the PAM for the current sizing recommendations. Here I'm going to set the node count in the pool to expand up to 2 nodes. And like I said, for an HA setup, you will need at least 3 nodes in the pool. I'm going to repeat the same sizing for the agent pool as well. And let's proceed. Again, mentioning that mostly I plan to go with the default options here, mostly to keep my demo flow simple. For example, I'll expose this as a public cluster, and obviously you may harden this based on your IT and security recommendations for your organization. So this can really be customized based on how you would like to do this. And with those settings dialed in, let's finalize and create. The cluster creation will take a few minutes, and once created, let's navigate to the resource. Now at this point, the objective is to get hold of the kubeconfig file for this cluster. I'm sure there are many ways to do this. What I would like to do is to go to the connect from UI, which basically makes it easy for me to connect to a Cloud Shell environment. The Cloud Shell makes it easy to configure the AZ command line, and once you are dialed in, it prepares a file location from where the kubeconfig file can be copied from. And we will do this in the old-fashioned way. Print out the file and make it available locally. To make this easier, let's save this to our local Kubernetes environment's kube folder so that configuring the kubectl environment will be simpler subsequently. Let's now head back and resume the edge node creation step. Back to the ELM wizard. Let's upload the newly created kubeconfig file. In case there are multiple contexts, select the intended one and propose a password that will be needed at a later step. All this information is encoded as a bootstrapping context file that we will download now. After this, next let's download the ELM Bridge disk installer file from the linked SAP Service Marketplace location. Make sure your P, I, or C user has the required download permissions from Service Marketplace. I am downloading the installer for Mac OS. In your case, make sure to download the installer for the OS that you intend to run the command line from. Let's copy the files we have downloaded so far in a separate folder location. You may rename the ELM installer file for convenience. The next step in the sequence is to execute the ELM Bridge bootstrapping process from the command line. Since I'm working on a Mac OS machine, I don't have the installer file directly, so I'll have to mount the installer to my local file system, extract the ELM Bridge executable file, and paste it to the same location where the context file is also placed. The HDI-util command on Mac OS lets me do so. Finally, I'm starting the bootstrapping process by running the ELM executables init command with the context file as a parameter. To proceed with the installation, I'll have to verify by providing the same context password I had proposed in the previous step. You will remember that I had selected a public access to the Kubernetes management plane, the API server. So the commands to run the bootstrapping process can be executed from my local OS. But if that were not to be the case, then the command would need to be executed from a machine in the private network that will have access to the management plane. Something to keep in mind. This step will take a few minutes to complete. What it's essentially doing is setting up the connectivity and the paths for the software packages to move from the cloud-based central repository to the registry from where the edge software will be locally managed. Should there be any errors during the bootstrapping process, there will be a log file generated that will need further inspection. The next step is to proceed with the Edge Lifecycle Management, Edge Integration Services, and Integration Cell solution deployments. With the bootstrapping process completed, we head back to the ELM page and we should see that the system would have automatically kickstarted the process of deploying the base Edge Lifecycle Management solution. The process should take a couple of minutes to execute. Meanwhile, let's head back to the IAS tenant and access the monitoring application we had created. Within the OpenID Connect configuration, you now see that the endpoints have been configured here. We need to complete one small step, which is to make sure the name of the application is populated. This completes the monitoring and logging settings. Back in the ELM page, we now see that the base Edge Lifecycle Management solution has been successfully deployed. We can proceed with the deployment of the main components now. Click on Deploy Solution. This brings up a dialog. Let's select Edge Integration Cell and the latest solution version that is available. Now I'm going to keep my solution properties here mostly to the defaults, which is acceptable for a test or a demo system. The important aspects here are to mention just the name of the virtual host's key alias for now. We will upload the actual key pair in a later step. Likewise, we will need to mention the host name of our runtime's URL as well. My host name here is the alias dot the domain that I have the ownership for. Note that these values can be updated later as well. Let's move to the next step. Here it basically lets you know the other dependent components deployments that the system will perform on your behalf. Let's go to the next step. This is an important portion of the setting that you need to care for if you are performing an actual production grade deployment. Please refer to the documentation to learn more about mounting external storage classes and persistency blocks. We will cover this in a future video of this series. For now, I'll go with the defaults and not alter anything here. In the last step of the wizard, we can select additional load balancer properties, how the X forwarded for header should behave, and whether we want an internal IP or a public IP for the load balancer. I'll select Azure and go for a public load balancer. And finally, let's start the deployment. This process will take about 5 minutes, so let's come back after a quick coffee break. If you have followed along so far, congratulations, we are almost there. At this point, you should start seeing that all portions of the solutions are successfully deployed. If there are newer software versions available, you will see that message being presented as well. Let's log out. Once you re-log into the integration suite page, head over to settings, integrations, and here you should see the Edge node as a newly created runtime profile to manage. There is a new operations menu option as well. Here you get a quick snapshot of the health of your internal pods, and as a matter of fact, it also tells me that a new version of the Edge integration cell solution is available for me. The next step in the sequence is Keystore management for HTTPS or SSL termination. Click on Monitor, Integrations and APIs, and you should see a combo box drop down with the available runtimes. As you can see, nothing exists yet in my cell runtime. Let's go to the Keystore style, and with the runtime filter set to all, let's bring up a dialog to create a new Keystore. Let's give this a name, and I also mentioned that this Keystore will be confined to the Edge runtime alone and nowhere else. Next, let me bring up a dialog to add a key pair. Like I did mention in the prerequisite section, I have a CS certificate and a private key pair that I will encode together as a PFX file in OpenSSL, present a password, and generate. Let's browse and load the key pair file. Here, an important aspect is to ensure that we maintain the same name of the alias that we specified in the previous step. Present the password and add. The key pair has been added, and let's refresh. After this step, the certificates should be available on the Istio Ingress Gateway. As a verification step, you can either bring up your local kubectl environment, or as I'm doing, just use the Azure Cloud Shell and query for the gateway resource on the Edge ISIL namespace, and sure enough, you should see a default gateway. And this got created just 3 minutes ago. We are almost there. The final step is configuring the DNS mappings for our virtual host. To do that, first we'll need the IP address of the load balancer that the system provisioned for us. Please do keep in mind that hyperscalers do have the capability to assign a public IP address to load balancers. In case you are setting up a private Kubernetes environment, you will have to refer to your platform documentation to learn how to attach IP addresses. Here I'm logged into the Azure's Cloud Shell environment, and I can echo the IP address like so. What it's doing is filtering out the load balancer IP from the Istio Ingress Gateway service of the Istio system namespace. Next, I'm logging into the DNS controller's cockpit of my sample organization, and as you can see, I have enabled an A record mapping between the host.domain name and the retrieved IP address. You have to wait for a few minutes for the DNS propagation to happen across all global servers, and that pretty much completes your entire installation. To ascertain that everything is in order, let's do a quick verification. Here in my central design time, I have a very simple loopback iFlow that is deployed to the Edge integration cell runtime. In the monitoring perspective of the Edge runtime, you can see that the deployed iFlow exposes an endpoint on our Edge virtual host. Let's copy the URL and head to Postman. I'm authenticating to the URL by presenting the client credentials from the central service instance for this tenant. I make a call with the retrieved bearer token, and sure enough, I get an HTTP status code 200. And if I can go back to my monitoring perspective, I can verify that a call did land on my Edge instance. This concludes the verification and the installation demonstration. So to summarize, we went through the basic installation steps for the Edge integration cell in Azure AKS using mostly default options. In the upcoming videos of this series, we will look at a few variations of these. For example, how to enable HA, attaching external persistency, enabling different network options. So stay tuned, and thank you for watching.